So let's talk about the normal distribution. And if we're given an area, we're going to find the cutoff scores. So you can be given a percentage or a proportion. So what you will be given is you'll be given a problem that has the area, the mean, and the standard deviation. And again, the area could be given as a percentile or as a percentage. And if the area is given as a percentage, you're going to have to convert it to a decimal before entering it into the command. So you're going to do percentage divided by 100, and that'll give you the decimal value. So let's do an example. According to the American College Test, the ACT Math, results from the 2017 ACT testing found that students had a mean score of 20.7 with a standard deviation of 2, and we're assuming the distribution is normally distributed. Find the 75th percentile. Okay, so what we're looking for is we're trying to find the 75th percentile of scores, which meant that 75% of people had that score or less. So we can do this. I'm going to do this. We can do this in Minitab. So again, I have the directions here if you need it, but I'm just going to show you. So I'm going to go to Graph, Probability Distribution, View Probability, and hit OK. I'm going to put my mean, which is 20.7, my standard deviation, which is 2, and then I'm going to go to shaded area. We're going to do something a little bit different this time. Instead of doing the x value, we're going to do the probability, and we're going to do the left-tailed. And why are we going to do the left-tailed? Because remember I said I want to know the score for 75% and below. So I do that left tail, and then here I'm going to put in this 0.75. I don't put it in as a whole number. Again, I put it in as a decimal. And if I hit OK, this is what I get. All right, so let's break this down. My mean is 20.7. This area in red is 75% of the data. So remember, this whole curve under here, the red and the white is 1. This is 0.75 or 75% of the data. The value that is the boundary between the white and the red is 22.05. So that is my answer. So let's go look at it. The 75th percentile for the ACT math score is 22.05. So that means that's the score that divides the data from 75% on one side and 25% on the other. So that's how we did that. So think about it. We could do that with other things. Say if I wanted to do 25%, okay? So if I wanted to, we're just going to do 25% right fast. Go to Graph, Probability Distribution, go to View Probability, hit OK, go to Shaded Area, and then I'm going to just change this to 25%. And look, 25% of the data, 19.35. It's on that side. Let me show you another one, and this might help drive it home a little more. What if I do 50%? What do you think it's going to be if I do 50%? Look, it's the same as the mean. So remember, with normal distribution, the mean and the median equal each other, and I'm seeing that right here. 50% of the data is on the left of the mean, 50% of the data is on the right of the mean. Okay, so if I'm given percentile, that's how you do it. Let's look at an example that's kind of close to that, but a little different. So for example 2, men's heights are normally distributed with a mean of 69 inches and standard deviation of 2.8 inches. The standard casket has an inside length of 78 inches. A manufacturer of caskets wants to reduce production costs by making smaller caskets. What inside length would fit all men except the tallest 1%? Okay, so I want the top 1%. Right? That's different than what we've been looking at before with the percentiles. So let's go ahead and think about this. The top 1% is the same as, or the tallest 1% is the same as saying the top 1% are 0.01. So let me show you what I'm going to do, because I said the top, the highest. I don't want this area in the red to go to the left. I want it to go to the right. So I go to Graph, Probability Distribution Plot, hit View Probability. I'm going to change my mean on my standard deviation. So remember, it was 69 inches, and this becomes 2.8 inches for the standard deviation. Shaded area, keep it as probability, and now I'm going to do right tail, and I'm going to put 0.1 in. I'm not going to put 0.1 because that's 10%. I'm going to do 0.01 because I want the top 1%. I hit OK, and look, ooh, that worked for me. The area to the red is to the right, and it's the 1%. So all this area in white, is 99% or 0.99. So the value for the top 1% is 75.51 inches. Okay, so if I go back and I look at the thing again, so I said the inside length that would fit all men except the tallest 1% is 75.51 inches. And again, if you see the picture, the little area to the right is red and this is white. This is why I love Minitab. It's drawing your pictures. There's really no things you can think about. Say you flipped it. Say you did this. Don't do this. Don't do this. I'm just going to show it to you. So if I did it, but say I accidentally put left, that shows me the bottom 1%. And I don't want to do that. I want the top 1%. So that's why I picked the right tails. All right, let's do the last one. Example 3. Oops. Okay, so a citrus farmer who grows mandarin oranges finds that the diameter of mandarin oranges harvested on his farm follow a normal distribution with a mean diameter of 5.85 centimeters and a standard deviation of 0.24 centimeters. Okay, I've got that mean of 5.85 centimeters, and then I've got a standard deviation of 0.24, and I know it's normally distributed because it says it right here. Okay, so they're asking find the middle 30%. All right, we got to do something a little different one for this one. Okay, find the middle 30%. All right, so I'm going to do this. I'm going to go ahead and put my stuff in. Change my mean. So my mean is, again, 5.85, and my standard deviation is 0.24. Okay, middle 30%. So if I go here and look, I have this middle. So I can do it, but what's the issue? Well, the issue is I don't know if it's going to be correct. So let's go look and see. So again, I have the directions for you. Okay, so you want to do the tails, and I'll show you why. So I do this, and I'm going to go to tails. Okay, so I want this area you can see slightly in white. So what I'm going to do, and I explain it here. So if I'm looking for the middle 30%, okay, so if I'm looking for my middle 30%, which is the area in red, then that would mean both tails would be 70%. Okay, 30% in the middle, which means I have a remaining 70% in the tails. Well, what if I want to find the left tail or the right tail? So to do that, if I divide 70 in half, I get 35 for each tail. And I'm going to be really careful, and I'm going to say that for each tail. So I've got 0.35 for each tail. So that's what I'm going to do. I'm going to put here. I'm going to put this is 0.35. Oops. And then I'm going to hit OK. And look what it does for me. These area in red, this area over here is 0.35. This is 0.35. And this area in white is 0.30. So I kind of faked it. So I made it work for me, though, by even though I knew the middle, I could figure out my tails and then get the middle. So if I go back to my picture, the middle 30% for this farm are between 66.38 and 71.62. Does that make sense? So that's kind of how I did it. Again, middle, got the middle area, subtracted it from 1, got each tail, and then I got the value. Let's do another one with this. Say I wanted the middle 50%. Go to graph, go to here, go here again. Okay, still got the same mean and standard deviation. So now, okay, if I have 50% in the middle, that means I have 50% in my tails. Divide it by 2, I get 0.25 for each tail. Hit OK. So then, now the middle 50% ranges from 5.574 centimeters to 6.126 centimeters. Let's do one more to help drive it home. Let's say I want let's say I want 90%, that I feel like 90% of the crops are going to be between this diameter. So my middle is 90%, which means I only have 10 in the tails total. Divided by 2, I get 0.05. Excuse me. So if I hit OK, so look, 90% of my data for these oranges, their sizes will be, or diameter will be between 5.38 centimeters and 6.32 centimeters. That's how you do the between. So in this video, we did percentiles in example 1 that go to the left. Example 2 had percentiles that go to the right. And for this example 3, we did the middle.